And the goal of this lesson is to insert this table on the Excel file that we're preparing, and to calculate heating loads through the basement. So remember that that was the problem on a basement. If we have a heating system here in the basement and we have comfort temperature, the temperature tends to go out from inside to outside. And the path from this point to the outside, you have to go all the way up. Okay, so the path from this point to this point, you have to go all this through all this thickness of ground or soil. But if we are here, the path from inside to outside is just this, so it's shorter. So we have more thermal resistance in this. This is a natural thermal resistance without any thermal insulation, but we have a lot of soil, we have a lot of material, so it takes more, well, it's more difficult from for the heat to go from this point outside that from this point. So that's why corners are always, yeah, we have to maximize the thermal insulation always in corners, especially in basement. And this wall to roof or to ceiling transition in the basement, it's something that we have to protect. To do this, we have this table. I think this table is outdated because the R values that they are using, that this ARCH260 is using, they don't have anything to do with modern standards, with the passive house standards. So those are quite low. Okay. Anyway, this is the tool that we have, and probably in another version of ARCH260, they will add, nothing will add, they will change those values, but the procedure will be the same. We will have different R values versus an uninsulated wall, and then we will have to calculate it. Okay. But what are the thermal resistances of those values? If I think I told you that. If we have two thickness of thermal insulation, and the thermal insulation can be 0.2 or 0.3, 0.2. Then the thermal insulation, the R value is 10. Okay, so with 2 inches of thermal insulation, we get a U value of 10. Then what column do we have to select? This one. So if it's 10, we cannot go to 12, we have to go to 8. Okay, if we have 1 inch of thermal insulation, 0.2, then we have 5. Okay, so we get this column. So what's the, and how can we get 12? If we have 4 inches divided by 0.2, this is 20. Okay, so basically these 2 columns means that here we have 1 inch of thermal insulation, 2 inches of thermal insulation, and 4 inches of thermal insulation. But even 4 inches, it's something that nowadays it's something ridiculous. We're talking about 10 or 12 inches in our thermal insulation. So, and the R value that we are targeting is around 40 or 50. Okay, so those values are a little outdated, but I'm sure that in a new version of the ARCH260, they will change those values. But this is what we have now, and we have to understand what we have to do with them. So we have 4 columns, the uninsulated column, and then this would be 1 inch of thermal insulation, 2 inches, 4 inches. If we have more thermal insulation with this table, use this column. Okay. Again, if we have more than 6 feet in depth, you can always use this value. Okay, so imagine that we have, well, I'll do it in the Excel file, but if we have the 8th foot, then I would copy these numbers here. We have this path length through the soil. Well, this is not necessary. This is just to get an idea. If we want to go from this point to that point, according to this table, we have to go 0.6 feet up. Okay, from the corner to the outside, it would be 0.6 feet. And if we are at the bottom of the basement, and if we want to go up, this distance would be more than 10 feet. Okay, so this distance would be more than 10 feet. This is what this table means. So we don't need this path because we're not going to use it. We do need the depth, and then we need these values. Those values, I don't know, we have it in the ARCH, right? But I don't know what they mean. This is the sum of, so 0.63, it's 0.41 plus 0.22. And 0.79, it's 0.63 plus 0.16. So I don't know why we need this, but we have it. Okay, but we're not going to use it. So if we open our Excel file, I'm going to delete it and I'll do it again. So here I can prepare like another table. So here I'm going to type basement. Okay, and I will prepare. I have tables for walls, roofs, floors. So here I have the basement. And now I'm going to type here the different numbers that we can get in this table. So the first is the depth. So I will copy this column on this Excel file. If you want to keep the format, click here, and we have this format. And that's the depth. And the units are feet. The second column, I don't want this one, the path length, I don't need it. The second column is this value. So I can type it here. And this is the uninsulated. If we have a basement that is uninsulated, we will take this column. The following one is the R4.14. This one. And the values are these. Okay. The next one, it's R equals 8.3. And we get this column. And finally, it's R equals 12.4. And we get this one. Okay, so here we have the depth from 1 to 7. Then the version with an uninsulated basement. And here, if we want to, if you remember, this is 1 inch of thermal insulation. This is 2 inches. And that would be 4 inches of thermal insulation. Okay, and this is the R value. Maybe it's like this. So we have 1 inch, 2 inch, 4 inches of thermal insulation, and this is the uninsulated, so that would be 0 inches. Okay, that's it. And now I have to go over the assignment, what we have to do. So the assignment is the 929. So this is what you have to do today. So what you have to do? Calculate the thermal loads of the basement, and then you have to submit an Excel file and the PowerPoint with the total heat loads. And here we have roof, walls, windows, doors, floors with the basement, EBTU hours. Okay, so every time that I open an assignment, you have to submit the same PowerPoint file with all the slides on it. And this assignment, if I download it, yeah, this is it. We have a basement, 20 plus, okay, so those are the same numbers that you got on the first assignment, depending on your ID. So this is the rectangle that you have here for the roof and for the floor area of the basement. We have 7 feet below grade, so the height of the basement, it's 7 feet. Then the insulation, it's R9. Okay, so that's the R value of thermal insulation. If we have to select the right column, it would be this one. Okay, so if R is 9, we have to get this number. So it's around 2 inches of thermal insulation. But it says that it's 2 inches of thermal insulation applied to the top 1 foot of the wall below grade. Okay. For yesterday, I created this masterpiece. So what we are doing here is to apply the thermal insulation only the first foot at the top. So I am just insulating this corner. And I wouldn't do that. Okay, so if I were designing a building from scratch, I would extend this thermal insulation and up to the floor. It doesn't make sense. But probably years ago, people would do this. So they understand that the maximum heat losses can be here, because here we have all these depth of this material. So this is the corner. It's all the dangerous points that people decided to apply a couple of thermal insulation on that corner. Okay, we're going to do that, but it's not the best strategy. And probably we will find out why it is not the best strategy. But this is the problem. Okay, but the basement, here we have heating system. There is the basement is 7 foot high. And we have thermal insulation only here on the first floor of the basement. So, and the rest of the wall is uninsulated. So in this column, okay, so I want to make sure that the final thermal conductivity, it's on the column where all the thermal conductivities are. And well, I have different columns here. So I'm going to apply the same format here. So the first foot is where the thermal insulation, the R value is 8. So I will highlight this one. And then the rest of the values, I have to take them from the uninsulated column, this one. Okay, because I only have 1 foot with thermal insulation. So what would I do here? This is the thermal conductivity, the thermal transmittance, the U value that I have to get. But in this case, in the basement, I don't have the U average. I have different U values in different slices of that basement. So I will type equals. So in this case, I take this value. This value. And the second, I take the uninsulated column, this one. And then the rest of the values are uninsulated, and I go this way. Okay. Now, I need to add another column, which is the perimeter. So the perimeter is this. Okay, imagine that my perimeter is 20 by 20. So this is 20, 20, 20, and 20. The perimeter is 80. Yours is different because you have different numbers here. So you have a different perimeter. But for me, this is 80. And it's 80 all the way down. So what's the final thermal load? Again, I always follow the same structure. So the last row is the thermal load, and I have to place the thermal loads on this column. So that equals, and what's the thermal load in this lesson? This is it. So it's the U value of the first foot times the perimeter times 72 minus 20. I can do this in every column. Okay, let's do this. Yesterday, I think I did something different, but what is the thermal load here? I'm going to use this. Okay, so this thermal load would be equals the U value of that first foot times the perimeter times, and this is indoor minus outdoor temperature. And the indoor minus outdoor temperature is this minus this. And then I can drag this down. And oh, what's wrong here? Yeah, I can't drag it down because this is only the first value, and I'm selecting this. The problem is that here, look at this. This is funny because if I do this, I'm taking this cell, and if I drag it, I take 0. Why? It's this cell, but this cell at the same time, it's okay, so I can't do this. Why? Because I didn't type here dollar and dollar. Okay, remember that I want, when I drag, I'm copying that structure. So I'm taking this, and then the cells that are just below these two. If we type dollar and I drag it down, now it works. Okay, because I'm always taking this cell times that cell, and with the dollar, I am always taking indoor minus outdoor temperature. And now what's the total thermal load? The total thermal load is the sum of all these columns, all these values. There you go. Okay, is it clear? What's the thermal load of the first foot of this house or this basement? It's the U value, 0.09, that I take from the this column with 2 inches of thermal insulation. Then the perimeter is always the same, and then indoor minus outdoor temperature. So the indoor minus outdoor temperature will be, I have to type the dollar because it's always the same to value. I'm going to do something different just for the sake of understanding this. Look at this. If this is the U value times the perimeter, if the perimeter doesn't change, I could do the same. So if I type in this column where the perimeter is dollar and dollar, and I drag it, now it works. Okay, so why dollar? Because I always use this number, and I always use these two temperatures, the indoor minus outdoor temperature. Okay, so if I only want to type the perimeter once, then I have to use the dollar in the formula, because that value is always referring to this cell where the dollar is. Okay, but now, yeah.
Do you need to rewrite the 0.9, 0.22, 0.16, or can you just know to take it from like E94?
From the, yeah, sure. I mean, this,
You're just doing it to make it simpler, right?
yeah, so
All right. So,
I'm doing, because if I if I drag this, then I'm taking this column.
yeah,
If you take this number, you can type here. Can be this one. And the value doesn't change. But if I drag it, now all the value is
the value
changing because
changes,
I'm
just taking
taking
that
this.
column.
Yeah, so that's why I did this.
so you're just making it simplified.
Okay, so that's why. But again, we know how to do it. We can do this with the Excel file. We can do this by hand or whatever. But now I have to add this value here. Okay, so I have to look at this. The total thermal load. By the way, don't forget the units. So now it's this thermal load is 3,494. Good, 3,494. So what? Probably we can use this here if we have the basement. This is 3,400. Well, let's say 3,500. Does it change our first analysis? So I think the first thing that we will do is to change the window. So this doesn't change that much. But probably this is the easiest way to implement. I mean, adding thermal insulation on the basement, it's very easy. Adding thermal insulation in the walls, it's more difficult, because probably if we want to add thermal insulation in this facade, what do we have to do? Probably we have to remove this drywall. And we remove this drywall, and then we add more thermal insulation there. So it's costly and it takes a lot of work. But probably on the basement, we don't have even a finish. Okay, so we don't have a finish. The basement wall, it's made of concrete and it's exposed concrete. So placing or sticking a panel of 2 inches of thermal insulation on that wall is the easiest way to do it. Okay, so probably I will start doing this. It's not because it's the most efficient measure. The most efficient one would be to change all the windows of the house, but probably this is the cheapest and the easiest time and the easiest way to do it. So if our client has a limited budget and he wants something fast, so that he can start saving money right away, so this is what I will do. I will add thermal insulation on the basement. And what does it mean? Okay, so this is the first option. So our energy or the power that we are using, it's 3,500. How can we do it easily? Just extend these 2 inches of thermal insulation. All the way down. Okay, so it's quite easy. Just extend that thermal insulation. And what can we get with this? So this is the second version. So I'm going to copy this here. And how can I make it change? Well, if now I get the values that I have in this column, in this column now, I have to get the same values. Okay, so I'm taking always the values of the column with 2 inches of thermal insulation. The perimeter is the same, it's 80. Those values have changed, and this value has changed. So now it's 1830. So what is the savings that we have just by adding 2 inches of thermal insulation around the basement? Yeah.
How did you get your values for the time? Because you said it was the 2 inch, right?
Yes.
But the values that went into the stuff. Yeah.
No, because in this place we have the original problem is this. I only have thermal insulation on the top one, and then the rest of the wall is uninsulated. So that's why the top one is going from 9, but the second foot, I think is the insulated color. But in this option, everything has thermal insulation. Okay. So here we have, and here we can say, okay, before refurbishing the building and after refurbishing the building. This is before, and this is after. So what are the savings? This is actually interesting because if you want to calculate savings, we can type before, and we get 3494 BTU hour after. Uh, 1830 BTU hour. Savings. The savings are always the before minus after. So it's 3494 minus 1830 divided by the original 3494 times 100. So what is the percentage of savings? I do this 3494 minus 1830, and I divide it by 3494 times 100. Okay, so this is 47%. So this is something that people will understand. 47%, round up 50% of savings. So this is the good news that you have to communicate your client. If you do this, you can save 50% of your energy. That means that you save 50% of the final heating or gas or electricity bill in your house, 50%. And everybody will understand that. If you say now we can save 1300 BTU hours, nobody knows what the BTU hour is or what the BTU is. But they know what the dollar is. So if you can tell them that you can save 50% on their electricity bill, that will be good news, and they will hire you because people want to believe good news. Okay, so they are tired of the bad news. No, there's nothing you can do. You are doomed to paying more every year, every month. Your electricity bill will keep growing, and you will, in a couple of years, you will barely have enough money to cover your expenses on energy. Really? Yes. No, don't say that. You say, no, I can save if you trust me and you give me your house to refurbish or to do an energy retrofit, I can save 50% of your electricity bill. Oh, sure. Can you do that? Yes. The other is how much does it cost me? Well, I don't know, doesn't matter yet. But the truth is that you can save 50% of the energy easily just by adding thermal insulation where you don't have it, increasing thermal insulation where you only have 6 inches, so add 4 inches more, get to the 10-inch thermal insulation, and then you get the passive house standards. And finally, or probably the first thing you have to do is to change all the windows. But it's quite easy. And the savings are incredibly high. Okay, so if you pay $600 per month or $1,000 per month, and you say that, okay, next winter you will pay only half, people won't believe it. And believe me, it works, and it's easy, and people they want to hear this good news, but probably they don't know. The owners of all these houses that are around him, they see that every year they pay more and more, and especially in winter, and they don't know what to do. We do know what to do, and it's quite easy. It's a question of analyzing these numbers. Okay, so what can we do? Windows, second, add thermal insulation. Where the area is bigger, so in this case, the wall and the basement are more important than the roof. I think I have told you before that roofs are more important than walls because heat tends to go up. But in this case, when we have a small area of roof and we have a huge area of walls, probably adding insulation on walls and basements makes more sense than adding insulation on the roof. But that depends on the building, and the building is this. So this, looking at this, we understand what the building is about. So that's the way we have to calculate the savings. We have the first option, the original state of our building. Then what we can do, so here we have the final thermal loads or heating loads of the building after our measures. And finally, we have this, the original minus the final, divided by the money or the energy that we spend on the original state, and then we can calculate the savings.